Okay, our last example in 6.1 is again a kind of an application type problem. This shows it's a table of values, right? It's a table of values. These are my x values. Here's my y values, and it represents an airplane landing starting at time 0. Okay, so time 0 could be, say, right now, right? And then we start counting, and we say right now the airplane's at 14. Well, 5 seconds later, it's dropped 2 meters. It's at 12 meters. Another 5 seconds later, it's dropped another 2 meters. Okay, so that's what's going on in this table. And I want to remind you, when we calculate our first differences, it's good. See how it goes up by the constant number 0, 5, 10, 15. It doesn't have to be ones as long as it's the same number every time. Okay, now it says here the question is to calculate the first differences. Well, like I say, we have to have the same number for x's every time or go up by the same number, and we do. And to calculate the first difference then, we just go 12 minus 14 is a negative number, negative 2, right? This one is 10 minus 12, which is negative 2. So it's constant, but it's negative, which makes sense in this application because, oops, 8 minus 10, negative 2, and 6 minus 8. It makes sense because the airplane is landing. So the height should be dropping, right? So that's part A. We've done our first differences. And just from a problem-solving point of view, just check mark, yep, done that. What does it represent? And so when it says what does first differences represent, what I would say, and I'll just put my answer to be right here, this means, what it means is that the height of the airplane is dropping, negative, dropping by 2 meters over every 5 seconds. I might use a text for that. So the height of the airplane, 2 meters every 5 seconds. I'll make that so you can read it. There we go. So that's my answer to part B. That's what the first differences represents, that the height of the airplane drops by 2 meters every 5 seconds. And it drops at a constant rate, right? If it was actually something in free fall, it would accelerate, right? And it would start to go faster, it gets closer to the ground. But this is dropping at a constant. It's a nice controlled landing. So 2 meters every 5 seconds. 5 seconds passes, drop by 2 meters. Okay? So we're done that one. And again, I really would like you to be in this habit of when you're answering questions, if sort of just, oh, I guess I wrote the answer there. First differences represent how far the plane drops every 5 seconds. Yep. Is it linear? Well, the answer is yes, because the first differences are constant, right? So my answer to C is yes. And that's done. So I'm just check marking to make sure as I go through the problem that I've done sort of every section of the problem. And then when will the plane hit the ground? And you can see right here, I just wrote a little how to do that. Extend the table of values using first differences until height equals 0. And so you're saying, what does she mean by that? Well, what I'm going to do is I'm just going to keep doing this table. So it goes down by 2 every time, right? So go down by 2, so this must be 4. Go down by 2, so that must be 2. And right here, height of 0, that's when it hits the ground, right? And so then you just have to extend, the question is asking when. And of course, this is a very interesting thing. You know, when you get a question, what is it looking for? Well, when must be the x value. It's the time, right? When is time? When means you're looking for time. So what we're going to do is we're going to fill in the table of values because the x's following the pattern, 5, 10, 15, 20. So it's going to go up by 5 seconds every time. So this would be 25, 30, 35. Okay, so that means that at 35 seconds it'll hit the ground. And that's my answer. Okay, and done. So now you're going to finish up this assignment. There's a few questions more. Okay, here they are. And you're going to start here, and I want you to finish when you see average speed. Okay, so when you get to this point, look at Charlie. He's very concerned. When you get to this point, then you're going to stop, and that'll be tomorrow's work.